Now students, till now we have discussed if the charges, where the charges are like charges or unlike charges, they are placed along a certain line, then we had to find out the electric field intensity or null point. These things we were discussing. Now the situation is slightly different. It is the question of CBSE 2014. Okay, it's regarding an equilateral triangle. See, an equilateral triangle. ABC is an equilateral triangle of the side length A, and at the two vertices B and C, the two charges plus Q and minus Q respectively are placed. Okay, what you have to do? You have to determine the electric field intensity, okay, at the point A. When I say you have to find out electric field intensity E vector, if I say you find out the electric field intensity E vector, okay, at this point A, it means you have to find out its magnitude as well as the direction. Both. Means my question is, you have to determine the magnitude and direction of electric field intensity at the point A. Fine? Okay. Then, what will happen? I remind you, this is an equilateral triangle. The two charges plus Q and minus Q are placed. Due to this charge plus Q, the field will be E1 vector. Always away from the positive charge. And E2 vector. Look, E2 vector. It is towards the negative charge. I hope it's clear. The directions are clear because directions are very important. Now what we shall do here? Here E1 must be equal to K Q by A square. Clear? E2 must be equal to K here 2Q by A square. I remind you again, we will never put a negative sign there. We will only put the magnitude. See, as I have put here 2Q, I put only the magnitude because just keep in your mind the direction is always adjusted, the sign is always adjusted by the direction because it's a vector quantity. Since it is a vector quantity, so the sign is always adjusted by the direction. So direction already has given. For the positive charge, away from the charge. For the negative charge, towards the charge, like this. So no problem is there. Okay. What we are doing? Here these two. Okay. Then, if I ask you what is the net field here, then obviously you can neither add nor subtract nothing because they are not acting along the same line. So what we have to do? Parallelogram law of vectors. Okay. Let us suppose the field is E vector. Net field is E vector. This is net field E vector. So by parallelogram law of vector addition, parallelogram law of vector addition, isn't it? What we shall have? E is equal to E1 square plus E2 square plus twice E1 E2 into cos. You see, each angle is 60 degree, then definitely this angle will be 120 degree. I hope you all are agreed to it. Now 120 degree and obviously a root over sign. Just be careful. I remind you, it is coming from the parallelogram law of vector addition. We have already discussed it in our class 11 syllabus. Okay. Now, if you just correlate, and once more I am coming here. If I correlate these two, may I write this equal to twice even, no problem, because magnitude wise it is the twice of the former. So we can write here root over even square is simply even square. E2 square is twice even whole square plus twice it is even into twice E2 into, is it minus 1 by 2? Just see how we have substituted. These two will be cancelled. Means how much we are getting, just look at this. This is 5 even square, and from this here 5 even 5 even square minus 2 even square. May I write it as 3 even square, that is even root 3. That means what is the value of E is equal to K Q by A square root 3. This is the value. Magnitude. We got the magnitude. So our this magnitude which we are getting K Q by A square into root 3. Now if it is a numerical values are given, you can substitute it and we can find out the value. Now what is the direction? Now direction. If the direction it is same, then what we have to do? We have to see that the resultant E vector should make certain angle either with E1 vector or E2 vector. Again I take the case of the parallelogram law. By the parallelogram law, look, if I consider it is forming an angle alpha, now I say let E vector is forming an angle alpha with E1 vector. So here alpha is angle made by E vector with E1 vector. Then according to parallelogram law, what we have? Tan alpha. I hope all of you know. Tan alpha is equal to what we write? E2 sine 120 degree by E1 plus E2 cos 120 degree. Once you check it, this is we are getting from the parallelogram law. Once you can consult parallelogram law of class 11, from there we are getting the angle formed by the resultant. The angle formed by the resultant, that we are getting tan alpha is equal to E2. If it is forming an angle alpha with E1, then we have to take E2 sine 120, the total angle, divided by E1 plus E2 cos 120. That means what is E2? E2 is definitely 2E1 divided by 2E1 into root 3 by 2. I hope you are agreed. Divided by E1 plus twice E1 into minus half. We can write it like this, no problem. That means 2 and 2 will be cancelled. So what we are getting? We are getting root 3, because this 2 and 2 will be cancelled, divided by root 3. E1 and E1 will be cancelled. That means 1. Can I write it? Half. I hope it is root 3. This is root 3 here and root 3 by 2. Just check it. Is it root 3 by 2? Look here. 1. Again here it is. Here we are getting E1 minus E1. Sorry. It should be 0. Anyway, you can see in this once you check this, how much you are getting. This is, I just give you the time. Once you check whether the solution is alright or not, you see how much you are getting. You can get the direction from here. Look at this first.